Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 907, sum of subarray minimums. And I would highly recommend you should read the problem statement and at least give 15 to 30 minutes before jumping to the solution in order to get why you need to watch this solution and also to get the intuition. So let's get into the solution. What problem is asking? You just need to return the sum of minimum of subarray. What I really mean is, let's take a test case. For example, this is subarray on its own. What is its minimum? 3. This is also, everyone is, every single element is subarray. Now, let's take these two. What is the minimum? 1. Now let's take 1 and 2. What is the minimum? 1. Now let's take this. Still the minimum is 1. Now let's take 2. 2, 4. What is the minimum? Even when we take this, the whole, what is the minimum is still 1. Even in this 3, 1, 2, what is the minimum? Still 1. How much we have got here? 3, 4, 8, 10, 10, 15, 16, 17, 17. Also, almost all subarray has been found. While doing this, while doing this, did you get something? Did you get something? Yeah, the brute force way. Make Savere and then find the minimum. In C++, it can be found using minimum star. This was syntax. This was the syntax. Uh, this may be the syntax. The iterator, the beginning iterator, the end iterator. That's it. Get the minimum, just add it. But it will be O square uh, on an average. But can we do better? Yeah, we can do better. Something to notice. While we were making one, not making, while we were having one as the minimum. Let's write it over here. Get more. When one was the minimum, this severate included, this severate included, this severate it was included, and in itself also, and in this also. What you can see is in how many times it contributed the minimum. 1, 2, 3, 4, 5. How many times? It contributed 5 times. 1, 1, 2, 3, 4, 5, 6. I'm getting 6 over here. Which did I miss? 1, 2, that we missed. Uh, we took 1, 2, we took 1, 3, we took 1, 2, 4. Are we missing something? 1, 2, 3, 4, 5, 5, and 6. We are missing something. We are 1, 2, 4, 1, 2, 1, 3. one in itself, one in itself, 21413, not 1331. 124, 124. Oh, what just happened, man? 12412, and it was so easy. Drag. Oh, 312. That I was missing. 312. 312. That's what happened when you do not prepare beforehand. Nonetheless, where were we? Now see, when you form these subarrays, you get the effect of one. We can get that effect of one without making uh, subarrays. How? I will introduce two terms, that is previous lowest and next lowest. For one, what is the previous lowest? Take it here as -1. What is the previous lowest? Nothing. And what is the next lowest? Take it here as n. Nothing. And while doing this next and previous, did you get some hint? If you didn't get it now, it's a monotonic stack. Why monotonic stack? Because in monotonic stack we store number in increasing and decreasing order. It has a fixed fashion of writing that function. You can do your research. I provided you the dot. Make it a line. It depends on your caliber and hardware. So let's get into the video. Not video. We are in the video solution. So if we find this next, not next, previous smallest and next smallest for one, we can easily get the contribution of this. There is a mathematical formula also to get this done. What it is what is this length? What is this length? This is 2, this is 3. 2 into 3 into 1. This is 6. Also 2, 6. 6 array formed. 6. It's just intuition, not intuition, by seeing that if you get this length and this length and multiply by the number itself, you get its contribution. This number of times 1 appeared. You can see it for yourself. 1 over here, 1 over here. I made, I can see only 5. 1, 2, 4, 1, 2, 3, 1, 1, 3, 1, 2, and 3, 1, 2, 4. 6. 6. 6 subarrays. So that's the trick for you. Get the next smallest, get the previous smallest, and by that, using their index, get the length from the previous smallest, get the length from the next smallest, multiply it, and also multiply that number. Because why? Why? Very basic thing. If you add 1, 1, 1, 1, 1 6 times, so you can write this. This is also 6. 1 times 6, basic multiplication. So the problem, not problem, the solution is like that. The particular number into the left and right. This is basically we are calculating the contribution of that number using this intuition. The left, right, just multiply with the number this many times. This was the minimum. So I hope you get what I'm talking. Let's summarize it. Take a number, have its previous smallest, have its next smallest, and using that right and left length, you can, uh, not summation, you can have its contribution. Contribution to what? The total sum that we would be getting into, that is left, that is right, left, and when you do it for other number, just do a sigma, not sigma summation, and you get the uh, whole total sum. What is the algo? Algo is like basic iterate over the element, obviously, while we are first computing left, while basic, not empty. And what should we do here? Whenever the number st dot out in the stack, in the stack we will be storing index, but because it is easier to handle, whenever the stack top is less less than nums nums uh, nums I, just pop it, pop. Why? Sorry, I did wrong over here. Num stop should be greater. It should be greater, and it is greater. Num stop should be greater. Stop should be greater. It's a mistake. Stop, because it wasn't making any sense. Num stop. Num stop. When this happen, because we want it in increasing order, and if top is greater than the current, so replace it, because smaller the first and while coming out of loop we will have a left. In left we will be storing the length simultaneously if stack is empty. If the current was the smallest, nothing previous left. What to do? What to do? What will be the length? If this one is the smallest and nothing left in the stack, what is this much length is? The index itself, the index plus 1, that is index plus 1. And if it is not present, sorry, if it is not empty, that someone is there, then what it should be is what it should be basic I minus st dot of basic, very basic, and st dot push, that same thing, that current. This way we calculate left. Left, by the way, is a vector for obvious reasons. Now calculating right. Left is previous smallest. Right is next smallest. Very similar like above, but but what we will be doing is, let me write it again over here. There are two things that we are doing. This time we have equal. Why equal? Because to handle duplicate. And also iteration is done from back. From back. Why duplicate? Why we didn't handle duplicate? We can handle over here also. We can handle over here also. But more intuitive is this. When you dry run your solution, you will see while going this, it doesn't make any uh, difficulty, but while doing this, some miscalculations are done. Because, for example, it, 3 1 2 3 2 4, get 3 over here also, get 2 over here also, get 2 over here. While if we do not put this condition over here, what we would be getting is this 3. But while, because we need the next next smallest, I took a very wrong example. It is like next greatest. I'll take a good example. uh, if you see this, 3 2 2 1, and 4 it is. If you see, if you do not have this condition over here, what you will be getting is this index. But what is correct is this index. So equal condition is put over there. I hope it makes sense. Let me erase it. Make room for the algo. How did ZZ come over here? Yes. Take my This much is clear. Same st.pop, little bit different over here is because we are calculating from the end this time. If this is not empty, this is not empty. We need, if this is not empty, let someone, we have someone smaller over here. Let's take an example over there also. 2 1. We have someone smaller over there. What should be the length? If we have someone smaller over there, then st dot top minus the current index, or if it is empty, nothing, he himself is the smallest. What to do? Because this time, what is the whole length? It is n minus the current index. This would be the length from here. Because this much is the length, this is the whole length, this is the index, then basic maths x, this x is right over here. Basic maths st dot push and we have right and left, and just basic for loop over that, right and left, num into left into right, and here we have our answer. Let's take the test case and dry run it. There is no need to dry run it, but still, for your better understanding and even for mine, because I also learn at the same time sometimes. So for 3, so for 3, let me read it again what I myself wrote. When it is empty, when it is empty, I plus 1, right, left, right, empty. Index is 0 1 2 3 4. Index plus 1 0 plus 1 1. Okay, it is in the stack. When now top is greater than pop, but now again, again it it is empty, the stack is empty. At that time what we will be doing it, what we will be doing is I plus 1. Index, current index is 1, so now it's 2. Stack is having 1, now 2, it is greater than, so it can be put. This time what should be inside, because it's it is not empty at that time. Before putting it, it was not empty. Pushing that is last step. I by mistake wrote it first, but this time stack was not empty. So at that time what I wrote is I minus top. Current index is 2, top is 1. So 1. The 2 is pushed. Let me write again. 2 is on the top. Again 4 this time. Why I am writing before. 4 this time. No popping because 2 is smaller. But stack is not empty. At that time what we do is 3 minus the top. Top is 2. We get a 1 over here. Now we will process the left. No, sorry. We processed the left. Now we will process the right. For right we will iterate from here. For left we did from here. From right, we will iterate from right. It makes sense. Left iteration, right iteration. For your understanding. So what we're gonna do? Empty the stack. Empty. You can take vector because it has clear function. So nonetheless, 4 stack is empty. This time stack was empty. Why I am pushing? When 4 was processed, stack was empty. What we were doing is when the stack is empty, is n minus I. If stack is empty, yes, n minus I. N minus I. What is the n currently? N is 5 and current index is 4. We get a 1 over here. Now 4 is pushed again 2. Stack top is greater. So and it is an increasing stack. It has to be popped out. Again, we have nothing in the stack. What we will be getting is 5 minus, this is 4, this is 3, 5, this is 4, 4 minus 4 minus 2, 2. Now comes the 1, 2 is pushed, but it is increasing stack. It will be popped 1. Stack is empty again. What will happen? 4 minus 1. This time again 3. 1 is pushed. What will happen again when 3 is processed? Top is smaller. Nothing will be popped. Something is in the top. Then what we will be doing is st top. Top is 1. Top is 1 minus the current. What is it? 1. Left to the left. 1 into 1 into 3. 3. 6 into 1. 6. 4. 4. 4. 4. 6. 10. 4 plus 3. 7. And that is 17. Hope you get the solution. I dry run it. I explained every little bit. So let's get into the code, shall we? Like Thomas Shelby. The size it took a mod because written in the problem. Understandable. Everything same. What I taught. Empty the stack before computing the right. We can even initialize one, but I will not recommend it because you have already occupied the space. So you should use the space that you occupied previously. And then when you have not contributed calculated, then just as discussed left right, that is handling of overflow. You can use pen and paper, understand it yourself, and at the end you just return the result. That's it. See if it is running or not. Yeah, it is running. So hope you guys enjoyed it, learned something new. I hope I was intuitive enough. I provide some value to it, not value to you. So before going, our motto: keep grinding. You guys are best. See you in the next one. Bye bye. Bye bye. Bye bye. Bye bye.